Welcome to today's classes. Dear children, today we can discuss some important points from vectors. With two sessions, we can cover up the whole theory from these vectors. This is the first part. What is a vector? A physical quantity having magnitude and direction, like force, weight of a body, acceleration, electric field, magnetic field. All these kind of quantities are coming under vectors. A vector can be represented by an arrow with a tail and a head. This length is the magnitude of the vector. It's a very simple concept which everybody knows. Then we know different types of vectors. Let us see the first type coming under. That is equal vectors, unequal vectors, like vectors, unlike vectors. What is like vector? The vectors which are having same direction are known as like vectors. Vector A, vector B are like vectors. They have same direction. Any magnitude other than 0. The special case of like vector is equal vector. So these are like vectors. What are equal vectors? Vectors are said to be equal vectors. They have same direction, same magnitude. Look at vector A, vector B. Both are having same direction, so they are like vectors. They have same magnitude, so they are said to be equal vectors. So all equal vectors are like vectors, but all like vectors need not be equal vector. When vectors are equal, we can write vector A equal vector B. Next, unlike vectors. What are unlike vectors? Vectors with opposite direction. See, vector P and vector Q, they have opposite direction, irrespective of the magnitude other than 0. Magnitude can be equal, magnitude can be different, but the direction is opposite. Don't use the word unequal or different direction. Different direction means it can be this way or this way. Then they are not unlike vectors. So never use the term different directions. It must be opposite direction to express unlike vectors. The special case of unlike vector, the special case of unlike vector is negative vectors. Negative vectors. That means vectors with same magnitude but opposite direction. Vector A, negative of A. These are negative vectors. So negative vectors have same magnitude but opposite direction. Next type of vectors, collinear vectors. Children, tell me what is meant by collinear vectors. What are collinear vectors? Vectors lying on the same line of action. See, collinear vectors. Vectors lying on the same line. Say vector A. Say vector B. If we draw a line on the same line only, A and B are line. That is why they are called collinear vectors. What about a vector lying on the same line but opposite direction? Say C. Whether all these three are collinear? Yes. So collinear vectors can have same direction or opposite direction. Now, how can we express two collinear vectors? Vector A equals lambda into vector B, where lambda is not equal to 0. Why? What happens when it is 0? When lambda is 0, A is equated with a 0 vector. 0 vector direction is indeterminate. So any direction we can assume. That is why we are making lambda not equal to 0. When lambda is positive, greater than 0, A and B are in the same direction. So the angle between them, theta, will be 0 degree. Suppose lambda is less than 0, means negative. Then like A vector and C vector, they have opposite direction. That means their theta is 180 degree or pi radian. So this is the way collinear vectors are expressed. Parallel vectors. Vectors which are parallel. Vector A, vector B. So these two vectors can also be represented by A is equal to lambda B. So remember, vector A equal to lambda into vector B can be for both type of vectors, collinear as well as parallel vectors. Now children, next, co-terminal vectors, co-initial vectors, co-planar vectors. All are starting with the collinear. Then co-initial. What is co-initial? Vectors are said to be co-initial if they have the same initial point. Co-initial vectors. So initial point is same. Vector A, vector B, vector C, vector D. See, all the vectors are having initial point same. So all these vectors are co-initial vectors. They have different directions. Co-terminal vectors. Terminal points are same. See, vector A, vector B, vector C, vector D. All these vectors terminal points, see arrow is the terminal part, remain same. So this is the way co-terminal vectors we are representing. Next, co-starting, co-planar. What is co-planar? They are lying on the same plane. Any direction, all these are co-planar vectors. So collinear, co-initial, co-terminal, co-planar. These are different varieties of vectors. Let us see what is meant by pseudo vector. What is pseudo vector? Or it is called null vector. A null vector is a vector whose magnitude is 0 and direction is indeterminate. Direction of a zero vector is indeterminate. It is usually represented by letter O with a vector. Next, what about next type of vector? That is unit vector. Unit vector, the word itself is unit, one unit. If there is a non-zero vector A, you can consider a small vector along A, that is a baby vector, small vector, that is represented by A cap. So A cap has a magnitude 1 unit. So that type of so many vectors you can add up to get a vector A. How many times you should add? Whatever be the magnitude, that many times A cap should be added. So A cap vector, magnitude of the vector A times when you add, you will get vector A. So what is A cap? Vector A divided by modulus of A, provided modulus of A is not equal zero. So one thing is very interesting. A pseudo vector whose magnitude is 0 has no unit vector. So which among the following has no unit vector? Such questions comes, search whether pseudo vector is there in the option. So zero vectors are having, or null vectors are having no unit vector. All other vectors are having, all non-zero vectors are having unit vector. Now, a vector A has two types of unit vector. One is plus A cap, next is minus A cap. A cap will be same direction of A, minus A cap will be opposite direction of vector A. Now, consider the components of a vector. See, x-axis, y-axis, next axis, z. Origin. Let us mark a point P whose coordinate is x1, y1, z1. Join P vector P with O. That is called vector OP R. This vector R is making an angle alpha with x-axis, beta with y-axis, gamma with z-axis. How can we write vector OP? That is called a position vector of the point P. So R vector is OP x1 I cap plus y1 j cap plus z1 k cap. its magnitude is root of x1 square plus y1 square plus z1 square. Magnitude of the vector is root of x1 square plus y1 square plus z1 square. Now, so many details regarding this vector or we can explain. Point number one, guys. X, y, z or x1, y1, z1 of this vector are known as, we can call it as scalar components of the vector. Scalar components. So if a question is there, find the scalar components, just pick up x, y, z. The same thing is called direction ratios of the vector. Direction ratios of the vector. Next point is the same x1, y1, z1 we can call as projection of the vector along x-axis, y-axis, z-axis. Projection on x, y, z axis. Now, alpha, beta, gamma are the angles made by the vector, means the cosine of those angles like cos alpha, cos beta, next cos gamma are known as direction cosines, cos of the angles made by the vector. Usually L, M, N are the letters we are representing for direction cosines. Now guys, these direction cosines are having some relation. What are the relation? Cos square alpha plus cos square beta plus cos square gamma is always equal to 1, or L square plus M square plus N square is equal to 1. And what will be sine square relation then? Sine square alpha plus sine square beta plus sine square gamma? 2. Sine square alpha plus sine square beta plus sine square gamma will be 2. How we are getting? Just to replace cos square as 1 minus sine square, you will get the result. From these two, when you subtract these two guys, cos square minus sine square, that is called cos 2 alpha. Cos square beta minus sine square beta, cos 2 beta. From trigonometry, recall. So we can write cos 2 alpha plus cos 2 beta plus cos 2 gamma. Value will be 1 minus 2 minus 1. These three results are very much needed regarding this direction cosines. Let us discuss one question. When the vector is r, 4i minus 3j plus 5k, direction ratios are 4, minus 3, 5. Direction ratios we can write drs 4, minus 3, 5. Or projection along x-axis. What is projection of the vector along x-axis? 4. Projection on y-axis minus 3. That means it is projected on negative y-axis. Projection on z-axis 5. What is magnitude of the vector? Root of 4 square 16 plus minus 3 square 9, 25. 25 plus 25 root 50, that is 5 root 2. Now what is direction cosines of this vector? Cos alpha. We know cos alpha has a formula, x1 vector divided by magnitude. x1 means 4 only, 4 divided by 5 root 2. Cos beta, we know it is y1 divided by modulus of r, or it is projection along y-axis divided by magnitude. What is projection on y-axis? Minus 3 divided by 5 root 2. What about cos gamma? Cos gamma is z1 divided by modulus of r. That is 5 divided by 5 root 2. 5 cancelled, 1 by root 2. That is a well-known result. Cos gamma 1 by root 2 means we can find what is gamma, 45 degree. That means this vector is making 45 degree with z-axis. So once a vector is given we can easily calculate what is the angle made by the vector with respective axis by using cos alpha, cos beta, cos gamma. What is angle made by r with x-axis? First you find cos alpha, then alpha. What is alpha? Cos inverse 4 by 5 root 2. Whatever it is, that will be the answer. What is angle made by y-axis? That is cos inverse negative 3 by 5 root 2. That is an obtuse angle. So whenever a vector makes alpha, beta, gamma with positive x, y, z axis, the negative vector, I will make it clear, if the vector AB makes angles alpha, beta, gamma with positive x, y, z axis, negative of AB, that is called the BA vector, makes angle pi minus alpha, pi minus beta, pi minus gamma with xyz axis. So direction cosines are alpha, cos beta, cos gamma. Then vector BA direction cosines will be cos pi minus alpha. From trigonometry, we know that is minus cos alpha. Minus cos alpha, minus cos beta, minus cos gamma will be direction cosines of vector BA, which is the negative vector of AB vector. Okay, next, let me erase all these points. Guys, see, a vector R equals 3i plus 5j plus 6k. The angle made by the vector, we know this is 3 divided by modulus of this vector. The same concept we can use for finding projection of a vector on different line or different vectors. Vector R, or let me write vector A, that is better. Vector A, there is a line, say L. If the vector A is making an angle theta with the line, projection of the vector A is nothing but from the extremes of the vector, say tail, drop a perpendicular from tail, that is already coinciding with the vector, so nothing to draw is a perpendicular. So this length perpendicular dropping, that is called a projection. This length is called a projection. So A vector will be projecting on the line L with a different angles theta. If theta is 0, projection of vector A on line L is equal to the same vector if theta is equal to 0 degree. That means if this is the vector A, making angle theta 0 means it is lying on the same line. So this length of this vector, that itself will be the projection. Suppose it is turned like this, say 180 degree, then the projection we have to say negative of the vector A. That means projection of A on the line L is equal to negative of the vector A if theta equal 180 degree. Or projection of vector AB, instead of A, if I take AB, will be same AB if theta is equal to 0 degree. AB vector become BA vector, that is negative of AB, which is called BA vector when theta is equal to 180 degree. Projection of A on the line L becomes 0 when theta is either pi by 2 90 degree or 3 pi by 2. Look at, if this vector is made like this, exactly perpendicular, what is projection of this? As I said, projection means from the extremes, tail and head, drop perpendicular. This is the tail. How can you drop perpendicular? The same point. From the head, that is arrow, how can you draw the perpendicular? Same point. So same point to same point, what is the distance? 0. So projection becomes 0 when theta is pi by 2, or it is turned 3 pi by 2, 270 degree. So both the cases, projection becomes 0. So it is a very important point regarding MCQs and all. AB become AB when theta is 0. AB become minus AB when theta is 180. The projection becomes 0 when theta is pi by 2 or 3 pi by 2. Guys, next point. Generally, a vector A and vector B, two vectors if I consider, the magnitude of both the vectors, mod of A plus B, will be equal to mod A plus mod B only when vectors are collinear and theta between them is 0. Theta equal to 0. That means, see, vector A, vector B. Magnitude of vector A this much plus magnitude of B this much, that is equal to magnitude of A plus B. So this whole vector is A plus B vector. So magnitude of this vector is equal to sum of magnitudes of these two. Look at what is angle between A and B? 0 degree. So this is an important relation. Modulus of A plus B equal mod A plus mod B implies theta is 0 degree. In general, there is an inequality. Mod of A plus B is less than mod A plus mod B, because vector A, vector B, which are not collinear, which are not making an angle 0, then this is A plus B. This is the third side of a triangle. You know, third side of a triangle is always less than sum of the other two sides. That is the general inequality. So if this condition is satisfied, vector A and B are not collinear. This is satisfied, vector A and B are collinear with the theta equal to 0 degree. So kindly remember all these points. Now we can see the dot product and scalar product. Dot product is nothing but scalar product. So dot product, another name is scalar product. And what is meant by dot product or what is meant by scalar product? When there are two vectors, vector A, vector B, making an angle theta. You know, theta varies from 0 to 180. 0 less than or equal to theta less than or equal to pi. Then there is a operation which is represented by A vector dot B vector, which is equal to modulus of A modulus of B cos theta, is pakka scalar. So dot product is a scalar quantity. This dot product becomes maximum. Any dot product of non-zero vectors has a maximum value, that is mod A into mod B. This is the maximum value possible, that is when theta is 0 degree. Minimum value of any dot product is minus A dot B, that is the minimum when theta is 180 degree or pi. Sometimes dot product becomes 0, you know, when theta is 90 degree. Then we can call the vectors mutually perpendicular or orthogonal vectors. Dot product can be positive. Dot product can be positive. Dot product can be negative. When dot product is positive, it lies, means the vectors are making an acute angle. So greater than or greater than 0 means the angle theta is between 0 and pi by 2. If it is greater than or equal to 0, then it can be 0 less than or equal to theta less than or equal to pi by 2. So greater than 0 means it can be equal to 0 also, because cos 0 is 1. 1 is greater than 0. So 0 less than or equal to theta, less than or equal to pi by 2. Why? Here it is closed interval and here it is open, because I cannot include pi by 2. When pi by 2 is included, it becomes 0. So if included, 0 is included, then see the inequality, see the difference. Then it can be less than 0, negative, dot product can be negative. Next, 90 to 180, that is pi by 2 less than theta less than pi. Under this interval, dot product A dot B will be negative. Under this interval, dot product can be positive. Here we cannot include this quantity. Pi by 2 cannot be included, but pi I can include. When pi is included, dot product become negative. That is the time negative minimum value we are getting. Correct now? Minimum value. So these inequalities and conditions, maximum value, minimum value, dot product is very important. So in general, A dot B varies from minus mod A mod B to plus mod A mod B. So there is a very important inequality. This is less than or equal to mod A mod B. So children, remember this inequality is a very important, that is called Cauchy's inequality. Mod of A dot B less than or equal to mod A into mod B. So these are the so important points regarding concept of vectors and dot product related things. The remaining things, more about dot product and cross product, I will discuss in the next video. Thank you.